Number 2, lesson 2-5, example 5, writing a quadratic equation in vertex form. We're going to write the equation y equals negative 2x squared plus 10x plus 1 in vertex form and graph it. And we want to identify the maximum or minimum value of the graph as well, which is probably going to be our vertex, right? So first of all, we want to write it in vertex form and graph it. And in order to graph it, it's easier to graph it from the vertex form because we have the vertex, right? Obviously. And so remember what your vertex form was. Y minus k, where k is your y value of your vertex, is equal to a times x minus h squared. Right? That's your vertex form of quadratics. So what we want is a factor here, a perfect factor, x minus h squared. So in order to do that, we have to make the terms that have the variable x as the perfect square trinomial. So first of all, look at your original equation. This is not a perfect square trinomial. In order to make it a perfect square trinomial, first of all, you want 1x squared, positive 1x squared, and then whatever b is for that x, that 1x squared would be your b. And then you're going to figure out negative b over 2 squared in order to figure out your value, right? So then you're going to add the perfect value to make it a perfect square trinomial to complete the square. But here is where you will find it confusing, right? So first of all, you're going to factor out negative 2 here. Well, before that, you have to subtract 1, but you already know why. And then here, we need to make positive 1x squared for your first term. So we're gonna factor out negative 2 first, right? And that's going to be GCF. You can divide negative 2 on both sides, but that's not necessary right now. So you can keep it. You can just factor it out. And then make sure that your b is the factored out form from your GCF. And that's going to be your b. And so using that b, you're going to figure out negative b over 2 squared, which is going to be 6.25. And you're going to add 6.25 on both sides. But instead of adding 6.25 on the other side over here, what we're going to do is that we're subtracting 2 times 6.25 because we forgot about this factor, right? So all of this all of this term should have been divided by negative 2. But since we are adding 6.25 inside the parentheses, what we're actually doing here is that if you multiply this out, right, using distributive property, 6.25 is actually going to be multiplied by negative 2 and become a negative 12.5, right? And so that's what we have right now. We added negative 12.5. And so we have to add the same number, not just 6.25. So don't forget about your negative 2 that was factored out here. And so you can do that inside your parentheses because we don't want to make y into a 1 over 2 y, right? Or y over 2. We want to keep the y because we want a clean y in the vertex form. So we're going to take care of that later. And so this is where it could get a little bit confusing, but just remember you can factor out your GCF, but when you're adding your c in your constant to complete the square, remember your greatest common factor, you multiply them and then you add the same number on the other side to balance your equation. Okay, and then you can simplify by factoring it out, x minus 2.5 squared would be your factor times negative 2. And this is where it should actually be, right? Your a needs to be here. And so you're gonna keep it there. And then whatever remaining would be your k. Y minus 13.5 would be would be your constants over here, right? Negative 12.5 minus 1 would be negative 13.5, and that's going to be your k, 13.5. Your h is 2.5, and so we already have a vertex, and this is your vertex form, right? This is already a vertex form. So this is, actually your vertex form needs to be in a times x minus h squared plus k. I forgot to add k on both sides. And so this is going to be your vertex form. And so your k is going to be 13.5. And this is why your k is added here and your h is subtracted here. It's actually both supposed to be subtracted. But we made it easier for us to see because we're writing in terms of y. And so this is the vertex form. And your vertex is right here, 2.5, comma 13.5. And then we know this is the maximum, so your maximum would be 13.5 when x is 2.5, y is 13.5, and that's your vertex. And then in order to graph them, you can figure out other points by plugging in numbers, okay? So you would plug in numbers and find a few other points and graph them. So at the end, you want to answer it. The graph of this equation is a parabola that opens downwards, so it has a maximum of y equals 13.5 at x equals 2.5 after you graph them. So when you're graphing, don't forget to label your x and y axes and label your units for your graph, your grid lines, so that you know the points represents something, right? Because this is going to be by 1, but here is 2.5 each, right? So they can represent different units. So in order for your points to be accurate, your grid line has to be labeled correctly. All right, so that was the last example, example 5. If you know how to write a quadratic equation in vertex form and graph them and identify the maximum or the minimum, then you're good with example 5. Let's try if you understood. So try number 5, you need to write each equation in vertex form, just like we did in example 5. You're going to identify the maximum or minimum value for each graph of the equation, just like we did in example 5. So pause the video and see if you can do it by yourself. Come back when you're ready for answers. Okay, are you ready? Okay, so 5a, you're going to start with subtracting 7 on both sides. And then factoring out negative 3, which is your greatest common factor. So that's going to be positive 3x. And then you're going to complete the square. First of all, you need to figure out what negative b over 2 square is. So negative 3 over 2 square would be 9. And don't forget to square your denominator, 4 over 4. So y minus 7. And then we need to know how much we're adding, because if we add plus 3x, if we add 9 plus 4, my pen, 9 plus 4, here we are actually multiplying negative 3 and we're adding that. So we have to multiply this by -3 in order to know exactly how big of a number we're multiplying, right? So negative 27 over 4 would be 6.75, or yeah, that would be the fraction we're adding, right? So make sure you're adding the same numbers to balance the equation. So that would equal to -3 times your perfect square. And then you're going to factor them out and simplify this expression. And that's going to be y minus 13.75. Let's use decimals. And then that's going to be -3 times x is equal to, why is my pen not working so well? Plus 3 over 2 squared. And so your vertex form would be y equals -3 times x plus 3 over 2 squared plus 13.75. Yeah. And then you're going to identify the maximum. I'm going to type because my pen is not working so well. Maximum is 13.75 when x is equal to -1.5. So in the same way, your vertex form for part B would be y is equal to 2 times x plus 3 square minus 9. And your minimum, this is going to be your minimum, is -9 when x is equal to -3. Okay, so that was try number 5. Please check your answers and see if you got it correct. If you did, good job. That was example 5, try number 5. Let's summarize our lesson. Key features of completing the square. So this is a visual that we can use to explain and understand why completing the square works and how it models using the area model. So the green section right here is the area that we need to complete the square because that's the area that's missing, right? So this area has to be added in order to complete this whole square. Otherwise, we're missing something. So that could be represented as -b over 2 squared, and that's where we got the -2 over b squared to complete the square, okay? So algebraically, you would use the steps to complete the square to figure out the solutions for x. And sometimes you have imaginary numbers as well, but but not always. So make sure you complete the square, factor them out, and solve for your x. That was lesson 2-5. Great job, guys. We'll continue with the next lesson in the next video. Bye!